I'm Dean Cifola, and this is the Azure Academy. So today we're picking up where we left off last time. We're building up our template so that we can have now multiple servers in our tiers, and then we're going to have multiple tiers all shown in a single template. And first thing I wanted to show you was our portal. So I've gone into our resource group and cleaned out everything so that we're starting fresh today. And here is our template. So one virtual network, availability set, network card, and VM are our resources. And then our simplified parameters for, we were calling out a tier name, which was web app or database, an instance count, which was 1 through 4 servers, specific sizes that we were allowing for our VMs, and either Windows or Linux. And then we were provisioning those resources with a specific name of our tier, web app or DB, and our VM name, and then a virtual network, and then one subnet reference with image references for Windows or Linux. So we didn't need more than this last time when we were proving out that all of this worked, but now in order to scale more, we need to make some changes. So for that, we're going to add more subnets because we're going to have different tiers for our application, and it's a good practice to separate your tiers in different subnets. That way you can isolate the traffic that goes to each tier. We're also going to have a load balancer for our web servers, which are going to be internet facing, so we want to secure those. And the web servers should not be able to talk directly to our database tier, so we want to block that. So we're going to need load balancers, we're going to need more subnets, and we're going to need to make some changes to how our code is originally laid out here so that we can scale and continue to grow from here for our application. So for that, first thing that we want to do is we want to go to our network and to our subnets, and we're going to change this from just one subnet called default, and we're going to add some more. A subnet for web, app, and database, and we're carving them out into /26 subnets out of our /16 address space. Which that also means is we need more subnet references to make our lives easier. And while we're at it, let's update our name for our resource ID. And that way, whatever resource group we deploy this into, we'll be able to have that reference ID correct. So now we'll need our subnet references for our web app and database. So now our virtual network is ready to scale. So that's good. Now we do need our tiers to be a little different. So we had a tier name originally, but this isn't really going to be applicable going forward because we're going to deploy all 3 tiers. So the name of the tier is not really going to be valid, so perhaps something else. And one thing that I usually recommend as we're building out resources is that we have some kind of prefix. And the prefix is something that's going to be tied to this build, tied to this environment or to the application, so that we know what it is that we're looking at, and also to keep our naming unique. So if you have some kind of resource that is globally unique, like a storage account or traffic manager or a key vault, that way you know that all of these resources are going to have a unique name globally, so you don't have any collisions. So that means if we're changing our prefix here, we've also got to change our parameter from tier name to prefix. So now we're going to get Z99 VM, and then that's going to translate to our network or our VM name here of Z99 VM0. So now that doesn't really work because we want to have that web in the name. And so we could do this in multiple ways. Okay, so I have 2 examples of what I'm thinking about. So the first one here, you can see in our JSON outline in Visual Studio that we're deploying servers here that we're distinctly calling out. So we've got a jump server, web server, app server, and database server. Now, each one of these, if we were to look at them, here's our web server. You can see it's got a copy and it does it by its number of instances. So same idea of what we had before. So you could deploy 2 web servers or 20 web servers. Okay, and every time you do, you'd get this web server configuration. And then the same thing for the database server. however many that you wanted, and then you would get that many VMs based on this configuration. So that's one way to do it. Now, the other way to do it would be to use some of our logic and our templates to our advantage. So you could do that like in this template. So here I have just a server type, and this is for DFS file servers. And what I've done here in the template is I've created this DFS info block. And in here I've got two items, and those items have multiple sub items as part of this array. And here's where I'm building one server, and then here's another server. And then that information gets piped down to our DFS server, where I'm doing the copy based on the number of blocks that I have, as I've shown you in our last video. And then every one of the parameters that are called out here are called out based upon what index you're in inside that block. And so you could do it this way as well. So because we're deploying a multi-tiered application, I think that this approach would work better as more of a big bang template. But if you wanted to have a smaller template that you could just deploy this time for web servers, next time for app servers, then you can do that as well. So it just depends on your requirements and which approach you like better. So based on that, I think we're going to go with this approach because I want to build a three-tiered application, and I know it's going to need the same three tiers every time. Okay, so back here in our template, so let's make this look like that other template just a little bit. So we'll take our network and our virtual machine here, and we'll add more instances of those as needed for building our three-tiered app. We're not going to build a jump server at this point. Okay, so here's the changes that we've made. So we've carved out 3 different tiers for our servers so they can all scale. And then we also have removed our virtual machine variable name, and we've replaced that inside each VM build. We've added a availability set array so that we can deploy availability sets for each of our tiers. And then inside each one of our NIC and VMs that we've got here, we've updated our name, so it'll have our prefix dash dbvm dash appvm, etc. And that's been updated, so our copy block names are updated and our dependency names are updated for our VMs on our NICs. And then we update the same things inside each one of our builds. So we update the availability set name to match what we're provisioning for that tier, the OS computer name, which is the name inside the operating system, the disk names to reflect which system they belong to, and the nicknames for the network cards, and there's our depends on interface. So let's deploy this, and this is again based on the instance count still, so number 1 through 4. So we could provision up to 12 servers from this template. Okay, our deployment is done, and here's what we have in the portal. So there's our Z99 prefix on all of our resources, so we know that this all belongs to the same application. And we've got one server deployed in each tier. So that's good. Let's verify that. And here's our subnet breakdown. Here's our connected NICs, and each one is on its own separate tier. So that's good. So now we need to add some more stuff to this to make it scale. So we're going to need a load balancer. Now, to provision a load balancer, we want to get that code written. Now, unlike the other resources that we could right-click and add in Visual Studio, a load balancer is not one of them. So we either rely on IntelliSense to write a load balancer, or we can go over to the Azure portal and we can spin up a load balancer from the marketplace. So we'll call this the Web ILB. This will be a public-facing load balancer, and we'll keep it as basic. And we'll create a new public IP for it. And we'll leave it dynamic, that's fine. And we'll put it in our existing resource group. So now we're going to hit OK on that. But first, I want to hit our Automate Options button. And this is what's going to be added. So we can just capture this code, and we can just stick this code right into Visual Studio as we provision it, because there's some more that we have to add here. but this will be a good start. Okay, now in order to make this code work, it parameterized some of our values, so I gotta undo some of that and clean this up here. So just give me a second. That's the basics for deploying a load balancer with a public IP address. And as you can see, one of the properties here in the load balancer front end is that public IP address. So this load balancer will not have an IP on our virtual network at all, but it'll just have the public facing front end, and then we'll have a back end that we'll have to create. And so let's go back to our portal. So there's our load balancer, and there's our front end pool calling the web public IP. Now let's create a back end. Okay, that's done. Now let's create a probe. Okay, there's our probe for port 80, and then we'll create a load balance rule. Okay, and there is our pool rule. And now if we look at the automation script, here is all of that information. Now, sometimes, as I've said before, looking at the automation script makes it a little difficult to pick out what code belongs to your resource. Where does that code stop? Where does the next one start? We try to make it as easy as possible by following these lines on our brackets, but sometimes it's just hard to see. So for that, I like to use the Resource Explorer, which I have pinned here on the sidebar, but you can also get to it from all services and scroll all the way down, and I've starred that so it shows up on my sidebar. And then we're going to go to our resource group and go to our resources. And here's our load balancer, so that way I see only the code related to the load balancer. And I will do a select all and copy, and I'll put that actually after the one that we've already typed here. Now, just so we can look at it, you can see that there are several differences in the code. For one thing, it's got all the resource IDs fully instantiated, okay? And then also it throws in things like these E tags and provisioning state and the ID, which is the full resource ID for that particular part of the load balancer. So a lot of this code we don't need. So I'm going to clean this up, particularly, like I said, the provisioning state, the E tags, and the IDs, and then we'll take a look at what we have. So we end up with our load balancer and our front end pool, back end pool, load balance rule, probes, and inbound NAT rules and pools, of which we did not have any, so those are empty. Here is a load balancer. Here's a public IP address, and that means that this early revision of this code we don't need, so we'll get rid of that guy. Okay, so now I'm just going to deploy this to make sure that our load balancer and public IP work correctly, and I'm not changing anything else. So it's just going to validate that these other resources already exist, so this should be pretty quick. Okay, that finished successfully, and just to look at our portal, you can see that there's nothing any different. There's our web IP and our load balancer. Now these things aren't following our naming convention yet with the Z99 prefix, so let's update that. And we'll do that by adding our concat function. Okay, and there it is, our concat prefix with the web ILB and web pip. So let's deploy that. Okay, now that deployed successfully. So let's look at our portal. And you can see we've got our Z99 load balancer and public IP, and we don't need these other resources, so we can delete these guys. All right, and now we have to get the NIC of our web server to be inside the load balancer. Now to do that, that is a property of the IP configuration. Okay, and I just went over to the backend pool reference that was in the load balancing rule and copied out that backend pool ID. And while we're here, let's update our tags. So now when we run this deployment, we should get our web server NICs inside the load balancer backend pool, which will mean that they are effectively load balanced. And then we just need to make it into an actual web server. Okay, so our deployment is done, and looking at the portal inside our load balancer backend pool, we now have our web server. So that's good. Now we need to add a network security group rule. Now, a network security group rule, like we've seen in the past, is what's going to allow or deny traffic either from the internet or within the virtual network itself. So we're going to call this Z99 Web NSG. And you can see the default rules are present. So now we're going to create an inbound rule. And this will be sourced from our service tag of internet on port 80. Okay, and there's our settings. So let's apply that. Okay, and then we'll associate this to the network card of our web server. Okay, now this is the way that things used to be done. So we would go into our virtual network, we would either segment by subnet or by individual NIC and do microsegmentation with our NSGs. But there is a new feature now called an application security group. And this is basically a metadata container that we can put virtual machines inside of and then associate that to our rules so that we can have one kind of rule for our subnets that would say allow traffic to come in from the internet, but don't allow it to talk to the database. But we can group that by a tag instead of having to know IP addresses or just do a blanket across a whole CIDR range. So it makes it a little bit easier to manage. Okay, here's our web app security group. Okay, now from the portal interface, you can't interact with it from here. You have to do that from the VM side. So here's our web VM, and then we'll configure the application security group here. Okay, so that's associated. Now let's go back to our NSG, and we'll change this rule. So our service tag where it comes in is still from the internet, but our destination is our app security group pool, and the rest of the information applies. So now any other servers that we put in that app security pool will get this NSG. So here we don't need this association. Okay, so back to our rules here. So the rule says that any VMs that are in this app security pool are going to be allowed from the internet on port 80 to destination of port 80. Okay, so now looking at this in code, and this is where the automation script really comes in handy. So now we've got a application security group, so we need that code. Our code now has been updated. I've moved things around a little bit just for organization. So we got our app and DB stuff down here since we're dealing primarily with the web layer right now. So I've added I've moved our public IP and load balancer up top and then created a application security group. And that's what the code looks like for that guy. And then I added him a copy block and a tag so we can easily reference it and have our nice display. And then we have our network security group, which references our application security group resource ID. So we'll have to variabilize that and clean it up along with some of the other stuff. And then aside from those, had to make some additions to our network card since that's where the application security group ties in using that same resource ID. We're going to try to deploy this now. And if all goes well, this should only take about a minute to validate everything since there's no changes because it's already all baked in the portal. And once that works, then we can variabilize it a little more and then build our extension for our web server. Okay, so that all deployed successfully. And in the portal, looking at our web server, under networking, we can see the association to our application security group, which pulls in our rule about port 80. So that's good. Last part of this is that we wanted to add our extension, and this is like we've done it in the past. We're using a bunch of references in our variables section here, and that is referencing a file that I've already stored up on a storage account in Azure. Could be there, could be in GitHub, as long as it's somewhere that's internet accessible. And based on that, I think we're going to do a deployment. All right, so we have successfully deployed, and I'll open a private browsing window here and go to our public IP address. And I got that public IP address off of our load balancer's public IP. So there's 4117.254.27. And there we go. And my custom script deployed a web server and deployed this custom tag into the server. So welcome, and then the name of the web server is Z99 Web VM1 Azure Fast Track Rocks. So that all works. That's great. Now we just have to do some variabilization, and then we're going to be done with this section. So give me a second to do that, and I'll show you what I've done. Okay, so what we have done is gone into each one of these reference IDs, and we have variabilized them. So now you could have done this through using the resource reference, and let me show you what one of those look like here. So this is the resource ID reference. The reason why I didn't do that, although it does work, is because I wanted to give the ability to be able to do this cross subscription. So this is if you want to call something from another subscription, another resource group, then you could do it in this fashion. So basically this is a big concat function, and we're taking our subscription ID and then the resource groups, resource group name, the provider name, which in this case for the load balancer is provider/Microsoft.network/load balancers, and then I'm sticking in my prefix with the load balancer name and then whatever the particular item is within the load balancer. And I've done that for every place where a ID appeared. So let's try to deploy this. Okay, so that worked. So let's open a new private browser. Okay, that works. So let's go back and open up that browser session. Okay, so deployment works great. So now that we've got this highly variabilized, we can now deploy more than one. So now we're going to change our deployment, and we're going to deploy 2 of each kind of server, and then we'll validate that we have failover between our web servers. Okay, so we finished our deployment, and here's our portal, and you can see now we have 2 servers in each role, and inside our availability set, 2 servers, and in our backend pool, 2 servers. And if we go back to our portal, there we go. So that's the first server, and that was 0. So let's take server number 1 and, oh wait, sorry, server 0, and let's reboot. And there you go. Server 1 is now online. Okay, so we've got rapid failover using our load balancer. We've got deployment of all of our services, and we have deployed at scale, highly available, using application security groups with network security groups to isolate and protect our network. And we did all of that from a very nice, neat, and convenient script, which we can scale further. And you can continue to expand on this, add other extensions to your web server for system configuration, add extensions to your app and database to build out your middle tier and your database tier. Continue to provision other kinds of load balancers for those other workloads that are internal facing only. Lock down your system more with network security group rules or the new Azure firewall. So lots of places that we could take it from here. And from this point, I'm going to actually switch gears in the automation, and we're going to continue down a different path of continuing with these concepts, but we're going to orchestrate now the deployment of environments. So we're going to take it from here from an application, and we're going to move up the stack so that we can deploy a single template that is going to then deploy multiple environments, different networks, lockdown and isolation, domain controllers, file servers, remote desktop infrastructure. We're going to go crazy here. So hope you enjoyed this. Like the video, subscribe, hit that notification icon so that you can find out when our videos drop as soon as possible. And thanks very much. And don't forget to comment. Tell me what it is that you guys are interested in, and I'll do videos on that.